Hello, in this video we are going to see how to calculate the uncertainty on a gradient. Let's assume that we arrived at this point where we have a graph, for example, of a mass of a certain number of balls of Play-Doh or plasticine against the cubic diameter of those balls. And let's assume that I was able to put the arrow bars in the y and the arrow bars in the x. So I have 5 points. All of those points, they have error bars. I can double click on the graph here and also see the uncertainty boxes if I want to. If it's too confusing, you can just remove them. Okay. Now, how do we calculate the uncertainty on the gradient? Well, first of all, I need to do the best fit analysis, right? And I know that this relationship should be proportional because I'm just trying to measure the density, and therefore I will click OK. I can already see here that I have a point that it's not exactly an outlier, and I can see it why. If I click on the uncertainty box, I can see that the box is going through the line, so I'm actually fine. And maybe I'm going to leave the box now in order for you to see better what I mean. So now this is my best fit. Now I need to, I will need to interpret this value here as related to the density, right, of the plasticine. And there is a factor before, which is pi over 6. So I will have to find out, okay, what's the density. But what is the uncertainty? Well, the uncertainty on this value, it's now given by LoggerPro by this other value, 0.02467. But if we want to do more a manual job, we can remove this uncertainty, and we can do it by hand, simply constructing a line of best fit with maximum slope and a line of best fit with the minimum possible slope. So I'm going to click on curve fit. I'm going to select linear, not proportional, and I'm going to try to fit it. And I will click here on manual, click OK. And the difference here now is that one is going to say auto fit, the other one is going to say manual fit. Let me double click on the manual fit. I'm going to click on enable line drag, and I'm going to change the color of these lines so it's clear to me that it's going to be the maximum. So for example, I can choose it to be red. So this is now my red line. And now I can see that I have 2 points here that can be moved. One is over here. Let me put it in such a way that I hit actually the top right corner of these data points, considering the arrow bars. And this point also here, you can drag it to the top left corner. This is the line with the maximum slope. I can see that actually I can be a bit more precise over here, and I can see that this line passes through all the uncertainty boxes of all the points. In case this was not possible, I would have to adjust this line, okay, depending on which point would best give me the opportunity to make the line steepest. Let me move it here. So this is my maximum slope, which is related to my maximum density in this case. Let me do also the minimum slope. I do the same thing. So linear, try to fit it, then manual. Okay, I'm going to double click here, enable, make it maybe, what do we want? Blue, royal blue. Ooh, okay. And this is going to be my minimum slope, so I have to be precise here and go from the bottom right corner of this last point to the top left corner of the first point. Okay. It seems kind of okay. Maybe it's a bit imprecise, but probably not too much. All right. And therefore, now I have all the numbers I need. I have the minimum slope, 0.5780. I have the best fit slope, which is 0.6715. And I have the highest possible slope, which is 1.004. All right,